Good morning, ladies and gentlemen. Let's get started. Now, this lesson is going to run exactly the same as normal, except for the minor detail that I'm not actually there with you. Now, this has a few implications. Firstly, I expect you to behave well for the relief teacher. Secondly, I may go too fast sometimes. So, in lessons, when I'm taking notes too quickly, you put up your hand and say, please stop, and then I scroll back up and you can take notes. In this, very simply, you do basically the same thing. You ask the relief teacher to please pause me, and they will pause this recording, or if necessary, you can literally rewind me and recover what I've been through. Now, today we're going to start quite a difficult section of algebra, and that is solving algebraic word problems. So, can you please get out your notebook and write down the title, Solving Algebraic Word Problems, and then write down the 5 broad steps that I've got outlined on the board, please. Now, these steps I call broad steps because algebraic word problems have a huge amount of variation. So I can't give you a step-by-step run-through of how to solve them. It isn't like Bay, expand the brackets, Shrek. Yeah? Each one is different, and you have to vary your approach to each one. But, simply, it starts off with reading the problem, and I can't stress that enough, I really can't. Read it, define a variable. Typically, that sentence means let x be whatever. But if you're looking for somebody's height or the amount of money someone earns, you could say let h be the height, or let m be the amount of money. It doesn't matter which variable you choose as long as you've defined it, and this lets whoever's reading know what's happening when you start introducing x's. Then you write an equation, solve the equation, and finally write the answer in words. If it asks for find the length of the triangle, or the triangle's hypotenuse, and you write x equals 3, well, that's not a very satisfying answer. Your answer really should be the length of the hypotenuse is 3. If they've asked it in a sentence, then you should be typically answering in a sentence. Alright, if you haven't copied those down, you may need to pause it because I'm going to move on. Today we're going to go through 3 examples, and they're 3 very different examples, but hopefully they give you a good spread of what to expect in the textbook, along with some ideas of how to solve it. Alright, so can you please copy the example in? And because in this recording I don't have to wait for you, I'm going to dive straight into solving it. Now remember step 1, read the equation. When a certain number is quadrupled and subtracted from 27, the result is 7 more than the number. Find the number. Having read the question, we want to define a variable. So we can say, let the number be x. Okay? So, when it mentions a certain number in our question, that number is x. And that's what we're trying to find. Now, step 2, if you remember. No, we're up to step 3. Write an equation. This sort of question makes the equation quite easy to set up. When a certain number is quadrupled, this means multiplied by 4, and subtracted from 27, the result means equal sign, is 7 more than the number. And more means plus. So, in equation terms, this would be 27 take 4 lots of our number is equal to 7 more than that number. Essentially, I'll read it through. X quadrupled is subtracted from 27. The result is 7 more than the number. Okay? Now what remains is for us to solve it. Solving the equation. Simply, we want to get all the x's on one side, because we don't like x's being on both sides. Now there's a couple of ways to do this, but remember we're thinking positive education. Let's make x as positive as possible. We're going to add 4x to both sides. On the left hand side, that leaves us with our 27, and on the right the 7 stays, and we add the like terms of x and 4x to make 5x. Now we want to start unwrapping that 5, and on the right hand side the furthest number away from 5 is 7, and we're going to subtract 7 away. So 20 is equal to 5x. Now we can see where this is going. We're going to want to divide the 5 away because it's 5 times x, so we undo the times by dividing, and simply x is equal to 4, or 4 is equal to x. Normally we would write it that way around, just by convention. Alright, now we have to remember step number 5. So write the answer in words. We found what x is, and remember x was our number, so we can simply say the number is 4. Alright, walking through it again. We've defined the variable, that's this step. We've written an equation, we've solved it, and then we've written our answer in words. Alright, now moving on to a slightly different type of question. A man is currently 3 times as old as his son. 4 years ago, he was 4 times as old as his son was then. How old is his son now? Alright, step 1, define the variable. And I'll give you a hint for which variable to define. Because you're probably thinking, well, do we make the man's age be x, or do we make his son's age be x? And the easiest way to go about this that normally works is think about what they're asking. If they're asking how old the son is, then we say, let the son's age be x. And remember, this worked with us before, up here where it said, find the number, and we said, well, let's make the number be x. Alright, let's make the son's age be x. Now with these sort of age questions, I like to draw up a bit of a table. You would use a ruler, I don't have one. And in this table we have the son and the man, and we have now, and we have the other time period they're talking about. So that is 4 years ago. And remember, we've already defined the son's age now to be x. And the equation tells us that currently the man is 3 times as old as his son. So in nowadays, in the now column, if the son is x, the man is 3x. Now, going from x back to this column is nice and easy. If his son's age is currently x years old, 4 years ago, his age, take 4. Similarly, the man, if his man's age is currently 3x, 4 years ago, his age was 3x, take 4. Now, how does this help us form an equation? Well, we form an equation by using this piece of information here. 4 years ago, he was 4 times as old as his son was then. That means that 4 years ago, the man was 4 times the age of the son. So, for example, if the son was 5, then the man would have been 20. Essentially, we take the son's age and we multiply it by 4, and that will equal the man's age. So, what we've done with real numbers will work equally well with x. We can take the son's age, multiply it by 4, and it will equal the man's age. So our equation will look like this. We have the son's age multiplied by 4. And note the brackets are important because we're taking all of son's age and we're multiplying it by 4, and that will be equal to the father's age. Alright, now we've got ourselves an equation. Things are looking a lot easier. So, we start by expanding brackets, simplifying. Remember, bay before anything else, expand brackets, simplify, get all the x's on one side, and then we're going to shrek it. So, expanding brackets. We have 4x take 4 times minus 4 is 16, equals 3x take 4. We are going to move all the x's to one side. Let's subtract 3x. 4x take 3x is simply x, minus 16 is equal to negative 4. We're going to get rid of that minus 16 by adding 16. And x is equal to 12. Alright, beautiful, we found our x. But that's not the end of the problem. Remember, they asked how old is his son now? We let the son's age now be x. We found x, but we need to answer in a sentence. The son is now 12 years old. Alright, so broadly the steps again. We defined our variable, and the hint we've got for defining our variable is by what it's asking for. These age problems very nicely set up in a table quite often. So we've set up a now and a then, and then we've set up an equation. And it's setting up the equation that's by far the most difficult bit in these questions. Alright, last example. Apples cost 27 cents each, and oranges cost 21 cents each. Nadia buys 5 more apples than oranges. The total cost is $3.27. How many apples and oranges did she buy? Alright. Now, here, we've read the question, we need to define a variable. So either we're looking at let x be the number of apples, or let x be the number of oranges. It wouldn't make a difference, both would work. However, my hint to you is, if she buys 5 more apples than oranges, the simple one is going to let's make x equal oranges, and that way the number of apples she buys will be x plus 5. So if in doubt, try and make the variable equal the simplest part of the sentence, or simplest part of the problem. The simplest part of the problem here is the number of oranges. And then the number of apples is simply 5 more than the number of oranges. So we can say, let the number of apples, whoops, after all that talking, I went with the wrong one. Let the number of oranges be x. Therefore, we can say number of apples is equal to x plus 5. Alright, so if she buys x number of oranges and each one costs 21 cents, what would the total amount of money she spends on oranges be? Well, it would be the 21 cents per orange multiplied by the number of oranges there are that she buys. Alright? Now, similarly with apples, the total cost of all her pile of apples will be the number of apples she buys, which is x plus 5, multiplied by the cost of each apple, 27 cents. And we know that if we add the cost of the oranges and the cost of the apples together, that is going to equal $3.27 or 327 cents. And we have an equation, which is awesome. Now, it doesn't look particularly nice, but remember, same principles apply as before. We want to expand and simplify. So, 21x plus 27 times x and 27 times 5 is, well, 27 lots of x plus 135. You can reach for your calculator if you don't trust me. And that is all equal to 327. Okay, now we collect like terms. 48x, because these are like terms, plus 135 is equal to 327. Now we go Shrek on the x, so we unwrap it, taking away the things furthest from it. $48x is equal to 192 divide both sides by 48. The pen is messing up. And therefore x is equal to 4. We haven't quite done yet because we haven't properly answered the question. We've simply found x. And note, it asks for how many apples and how many oranges did she buy. We don't just answer oranges, we need to answer both. So x was our number of oranges. We can say Nadia bought 4 oranges and 5 apples. No. 4 oranges and then x plus 5, so 9 apples. Okay. Thus ends the final example. Thank you for listening. Now, can you please work through these questions? If you finish them, move on to the homework sheet. Do help each other, because these are difficult questions and I'm afraid I'm not there to help you, and I do apologise about that. So essentially, you're a little on your own. If you get stuck, go back and look at the examples, ask each other, ask other maths teachers, and good luck. I will see you later, either next week or the week after. But for the lessons next week, you'll be hearing more videos. Enjoy!